disconnecting the neutral jumpers and installing two-pole ground fault circuit interrupter, or GFCI, breakers in the basement panels to feed the sub-panels is indeed a feasible solution. This approach offers ground fault protection for the receptacles within each suite. The process involves several crucial steps. Firstly, ensure safety by turning off the power to the basement panels at the main breaker or fuse. This eliminates the risk of electrical shock during the subsequent procedures. Secondly, carefully remove the covers from the basement panels. This allows access to the internal wiring and components necessary for the modification. Thirdly, precisely locate the sub-panel feeders. These are the wires that supply power from the main panel to the individual sub-panels in each suite. Disconnect the neutral jumpers that are currently connecting the neutral and ground. Fourthly, install the two-pole ground fault circuit interrupter, or GFCI, breakers in the basement panels. These breakers will replace the existing standard breakers for the sub-panel feeders. Ensure they are properly seated and connected according to the manufacturer's instructions. Fifthly, after the installation is complete, turn the power back on at the main breaker or fuse. Carefully test the ground fault circuit interrupter, or GFCI, breakers to confirm they are functioning correctly. This can typically be done by pressing the test button on the breaker and verifying that it trips. A critical consideration is ensuring that the sub-panels are properly grounded. The effectiveness of ground fault circuit interrupter, or GFCI, protection relies on a reliable ground connection. If the sub-panels lack proper grounding, the ground fault circuit interrupter, or GFCI, breakers will not be able to detect ground faults and provide the intended protection. To elaborate on the importance of grounding, it's essential to understand its role in electrical safety. Grounding provides a low resistance path for fault current to flow back to the source. This high current flow triggers the ground fault circuit interrupter, or GFCI, breaker to trip, quickly cutting off the power and preventing electrical shock. Without a proper ground, the fault current may not be high enough to trip the breaker, leaving a dangerous shock hazard. Therefore, before proceeding with the ground fault circuit interrupter, or GFCI, breaker installation, thoroughly inspect the grounding system of each sub-panel. Verify that a grounding conductor is present and properly connected to a grounding electrode, such as a ground rod or a metallic water pipe. The grounding conductor should run from the sub-panel back to the main panel, creating a continuous grounding path. If the sub-panels are not adequately grounded, address this issue before installing the ground fault circuit interrupter, or GFCI, breakers. This may involve installing new grounding electrodes, running new grounding conductors, or correcting any existing grounding deficiencies. Regarding the selection of ground fault circuit interrupter, or GFCI, breakers, it's crucial to choose the correct type and rating for the application. Two-pole breakers are required for circuits that supply both 120 volts and 240 volts, as is common in residential settings. The current rating of the breaker should match the ampacity of the circuit it is protecting. Consult the National Electrical Code, or NEC, for guidance on selecting the appropriate breaker size. When installing the ground fault circuit interrupter, or GFCI, breakers, pay close attention to the wiring connections. The breakers will have specific terminals for the line neutral and ground conductors. Ensure that each conductor is connected to the correct terminal following the manufacturer's instructions. Improper wiring can prevent the breaker from functioning correctly and may even create a safety hazard. After the installation is complete, thoroughly test the ground fault circuit interrupter, or GFCI, breakers to verify their functionality. The test button on the breaker simulates a ground fault, causing the breaker to trip. If the breaker does not trip when the test button is pressed, there may be a wiring problem or a defective breaker. Correct any issues before putting the circuit into service. In addition to the test button, it's also recommended to use a ground fault circuit interrupter, or GFCI, tester to verify the tripping time of the breaker. This tester applies a small ground fault current and measures the time it takes for the breaker to trip. The tripping time should be within the limits specified by the manufacturer and the National Electrical Code, or NEC. Regularly test the ground fault circuit interrupter, or GFCI, breakers to ensure they are functioning correctly. The National Electrical Code, or NEC recommends testing ground fault circuit interrupter, or GFCI, breakers at least once a month. This can be done by pressing the test button on the breaker. If the breaker fails to trip during the monthly test, it should be replaced immediately. Furthermore, it's essential to educate the residents of the rental property about the importance of ground fault circuit interrupter, or GFCI, protection and how to test the breakers. Provide them with clear instructions on how to use the test button and what to do if a breaker trips. Emphasize that ground fault circuit interrupter, or GFCI, breakers are designed to protect them from electrical shock and that they should never be bypassed or tampered with. By taking these steps, it is feasible to significantly enhance the electrical safety of the rental property and protect the tenants from potential hazards. It's important to note that electrical work can be dangerous and should only be performed by qualified individuals who are familiar with the National Electrical Code, or NEC, and other applicable electrical safety standards. If you are not comfortable performing this work yourself, it's best to hire a licensed electrician. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment. It is updated every 3 years and provides detailed guidance on how to install and maintain electrical systems safely. The National Electrical Code, or NEC, covers a wide range of topics including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for anyone working with electricity to be familiar with the National Electrical Code, or NEC, and to follow its requirements. In addition to the National Electrical Code, or NEC, there may be local electrical codes that apply to the rental property. These codes may be more stringent than the National Electrical Code, or NEC, and it is important to comply with them. Contact the local building department or electrical inspector to determine the applicable electrical codes for the property. When working with electricity, always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment such as insulated gloves and safety glasses. Never work on live electrical circuits. Always turn off the power at the main breaker or fuse before working on any electrical equipment. Use insulated tools and equipment. Be aware of your surroundings and avoid contact with grounded surfaces. If you are unsure about any aspect of the electrical work, consult with a qualified electrician. Remember, electrical safety is paramount. Taking the necessary precautions can prevent serious injury or death. By following the steps outlined above and adhering to all applicable electrical codes and safety standards, it is feasible to disconnect the neutral jumpers and install two-pole ground fault circuit interrupter, or GFCI, breakers in the basement panels to feed the sub-panels, providing enhanced ground fault protection for the receptacles in each suite. Also, remember to inspect and correct any grounding issues before proceeding with the ground fault circuit interrupter, or GFCI, installation to ensure the safety and effectiveness. Here is some additional information about ground fault circuit interrupters, or GFCIs. A ground fault circuit interrupter, or GFCI, is a safety device that protects people from electrical shock. It works by monitoring the current flowing in a circuit and quickly shutting off the power if it detects a ground fault. A ground fault occurs when electricity flows outside of its intended path, such as through a person's body. Ground fault circuit interrupters, or GFCIs, are required in many areas of the home, including bathrooms, kitchens, and outdoor locations. They are also recommended for use in any area where water may be present. There are two main types of ground fault circuit interrupters, or GFCIs. Firstly, receptacle ground fault circuit interrupters, or GFCIs, which are installed in place of a standard electrical outlet. Secondly, circuit breaker ground fault circuit interrupters, or GFCIs, which are installed in the electrical panel. Receptacle ground fault circuit interrupters, or GFCIs, are typically used to protect a single outlet, while circuit breaker ground fault circuit interrupters, or GFCIs, can protect an entire circuit. Ground fault circuit interrupters, or GFCIs, are designed to trip quickly, typically within 25 milliseconds, to prevent serious injury from electrical shock. They are also designed to be self-testing, so they can detect when they are not functioning properly. If a ground fault circuit interrupter, or GFCI, trips frequently, it may indicate a problem with the electrical system. In this case, it is important to have the system inspected by a qualified electrician. Ground fault circuit interrupters, or GFCIs, are an important safety device that can protect people from electrical shock. They should be installed in all areas where they are required and should be tested regularly to ensure they are functioning properly. When installing ground fault circuit interrupters, or GFCIs, it is important to follow the manufacturer's instructions carefully. Improper installation can prevent the ground fault circuit interrupter, or GFCI, from functioning properly and may even create a safety hazard. If you are not comfortable installing ground fault circuit interrupters or GFCIs yourself, it is best to hire a licensed electrician. It is also worth noting that arc fault circuit interrupters, or FCIs, are another type of safety device that is designed to protect against electrical fires. Arc fault circuit interrupters, or FCIs, work by detecting arc faults, which are dangerous electrical arcs that can occur when wires are damaged or overloaded. Arc fault circuit interrupters, or FCIs, are required in many areas of the home, including bedrooms and living rooms. They are also recommended for use in any area where there is a risk of electrical fires. While ground fault circuit interrupters, or GFCIs, protect against electrical shock, arc fault circuit interrupters, or FCIs, protect against electrical fires. Both types of devices are important for electrical safety and should be installed in all areas where they are required. In summary, disconnecting neutral jumpers and installing two-pole ground fault circuit interrupter, or GFCI, breakers is a feasible way to provide ground fault protection. Ensure proper grounding and follow all relevant electrical codes for safety.